Welcome back. This is lesson 9.1 journal. We are on page 120 of your math journal. Independent and dependent variables. I will be able to identify the differences between the independent and dependent variables. Independent variable and the dependent variable. In any real life situation. Vocabulary for this lesson are independent variable and dependent variable, so please pull out page 118, which is your vocabulary page. So the independent variable is the variable that is in charge or in control of the situation. It's also known as the input. The dependent variable is a variable that changes because of the independent variable in the situation. It's also known as the output. So you kind of think of like cause and effect. One thing has to happen before the other one can happen. Here would be an example. The faster I run, the more tired I get. I choose how fast I run, but because I run fast, I get more tired. So me choosing to run would be the independent variable. And how tired I am would be the dependent variable. Because I ran, I got tired. So that would be an example of an independent and dependent variable. We're going to now go back to the other page. And this says identify the variable, write I, and the dependent variable, write D, for each situation, and match the correct variables together for the situation. So the cost of a speeding ticket. Over here there's something that's going to match up with it. What could correlate with that? Are the scores on your math test going to control or be connected to the cost of a speeding ticket? Probably not. How much it rains? Probably not. The speed you're driving. Okay, that is something that is connected to the cost of a speeding ticket. Now, does the cost of the speeding ticket control the speed you drive? Or does the speed you're driving control the cost of a speeding ticket? In this case, you choose how fast you're going to drive, but if you're going to speed, your ticket is going to go up, or you're going to get a ticket at all for that matter. So this is the dependent variable. Because you chose to speed, the cost of your speeding ticket is going to change. You know the best cost of a speeding ticket? 0, don't get one. Okay? The winner of the football game. What would that go with here? Math test, probably not. How much it rains? I don't think so. How much education you've got? Probably not. Cell phone bill. Weight of the barbell you can lift. How cold you are. How much gas is in your tank. Who scores more points? Okay. Winning a football game has to do with scoring points. So these ones would be connected to each other. But which one's in control? Is the winner of the football game in control of who scores the most points? Or is who scores the most points in control of the winner? They have to score the points before they declare the winner. So this would be the independent variable. This would be the dependent variable. Okay? What about this one? How far you can drive. What over here would that connect to? That's going to be controlled or connected to how much gas is in your tank. Now, which one is going to control the situation? Does the amount of gas in your tank control how far you drive, or does how far you drive control the gas in your tank? This one could probably be debatable either way, but I'm more likely to say how much gas is in your gas tank is going to be able to control how far you're going to be able to drive. So this would be the independent variable, and this would be the dependent variable. All right, how much data you use. Which one of these would that connect with? Does how much data you use control how much it rains? Probably not. It's going to be connected with your cell phone bill. All right, so does your data use control your cell phone bill, or does your cell phone bill control your data use? Well, You get to pick how much data you use. So this is going to be the independent variable. You choose to use more data, that's going to make your cell phone bill go up. How much heat you use, what's that going to go to? How cold you are. Okay, is how much heat you use going to control how cold you are, or does how cold you are control how much heat you use? This one might be debatable as well. However, generally, how cold you feel is probably going to control how hot you set your heater. How much money you can earn. What would that go with here? How much it rains? Probably not. The weight of the barbell? Probably not. Your level of education. Generally speaking, the more education you get, the higher income you usually can make. Doctors go to school for 12 years, they make a lot more money than teachers that go to college for 4. So which one is going to control that? Do you control the level of your education, or do you control how much money you can earn? Your level of education probably is going to help dictate how much money you're going to earn. So independent would be how much education you get or training, and how much money you can earn depends on how much education you've got. Okay, how about this one? How tall the grass grows. Which one of these is going to affect that? How much it rains. Okay, so which one is in charge here? Does the grass growing control the rain, or does the rain falling control the grass growing? The rain's going to fall no matter what when it's going to. But because it rains, the grass is going to grow taller. So that would be the independent, and this would be the dependent. The amount of homework and studying you do. The scores on your math test, that's probably going to go together. Does this math test control your homework, or does the homework and studying control the score of your math test? Generally speaking, the more you study, the better you do on a test. So that's going to be in control of your math score. Okay, the strength of your biceps and the weight of the barbell you can lift. Because you're strong, that would be the independent, will control how much weight you can lift. However, the more you've been working on it, the heavier you can probably lift as well. Alright, hopefully that gives you a good idea about how independent and dependent variables are connected and how we can kind of distinguish which one is which. Now in each situation below, we're going to identify the independent variable and the dependent variable, define each variable, and 3, write an equation to represent the relationship between them. Okay, we've talked about writing equations. Now we're going to put some pieces together. So, Morgan must use 1 blue bead. Okay, she's got to use 1 blue bead. That right there is telling me that's going to be the independent. For every 10 red beads to maintain the pattern. So every time she puts in a blue bead, she has to use 10 red beads to continue the pattern. So I'm going to put blue beads as the independent variable. Now this one isn't quite as obvious of which one's the independent. You could probably put in 10 red beads before you put in the blue bead, but we're going to use blue beads for the independent here and red beads for the dependent. There are other situations where it's definitely one over the other. So here the red beads are going to be our dependent. So define a variable means I'm just going to say what each one of these is going to be represented by. So I'm going to represent blue beads with a B. Sorry, write a D, that's not very good. B. And then I'm going to represent red beads with an R. So, we're trying to figure out how to get the output. So, whenever I start an equation, it's easiest for me to think, how do I get my output? So, how do I figure out how many red beads she's going to need? So, output equals, how many beads would she start with when she starts making this bracelet? There's always a starting point. Well, before she's started doing anything on the bracelet, there's probably 0 beads. So there's my starting point. Now I need to decide, is it going to go up or is it going to go down from here? Well, she's going to be adding beads to it. Now here's where I got to find the connection. I've got to do something to the input to figure out the output. If Morgan uses 1 blue bead for every 10 red beads, isn't she going to be using 10 times the amount of red beads compared to blue beads? So that means our rate is going to be 10 times the number of blue beads. So think of it this way. If she uses 1 blue bead, 1 times it by 10, add it to the beginning amount of beads, which was 0, and that would give us the number of red beads. 1 blue bead is going to be 10 red beads. If she uses 3 blue beads, she's going to use a total of 3 times 10, which is 30 red beads. Now, you don't have to write this plus 0. I just like you to see where this situation starts. So the output starts at 0. We start with 0 red beads on the bracelet. Now, this could also be written R equals 10 times B, because it's not necessary to write that plus 0. However, in other situations, it's really nice to see that starting point, so I want you to get used to that idea. Okay, let's try this next one. For a party at the pool, it costs $100 to rent the pool, and then $2 for every person who comes. Alright, so here, what 2 things can change? Well, we got people in the pool and the cost of the pool. So which one's in control? Does the cost control the people coming, or does the people coming control the cost? You choose how many people to invite to the pool. So people here would be the independent variable. The number of people are going to change how much it costs in dollars. So for people, I'm going to call it P, and for costs, I'm just going to call it C. But once I define the variable, that helps me when I look at my equation to know what I'm talking about. Okay, we always do output equals first. How do I figure out the cost? So mathematically speaking, remember how I talked about a starting point over here? Where does the start of your cost begin? Well, no matter what, even if 0 people come to your party, how much is the pool going to cost you? It's going to cost $100 no matter what. Then what's going to happen to your party, or to your cost? Is it going to go up or is it going to go down? Well, it's going to increase for every person that shows up. So how much is it going to increase for every person? $2 for every person who comes. So that means I got to take the number of people and I got to times it by 2. So 2 times the number of people who come. So here we go. Make sure it works. Start with $100 to rent the pool, plus it's going to go up $2 for every person. So over here I could read this. It's going to start at 0 red beads, and then it's going to go up 10 for every. For every is a good way of reading a time sign. Blue bead. If you can make that statement, then it will help you make sure your equations are correct. Alright, Ryan is 500 feet up the cliff and rappels down 6 feet every second. Okay, so what's in charge here? Well, if he's rappelling down, we're talking about height on the cliff, and seconds is time. Okay, so if we got time and height, does the height control the time, or does the time passing control how high he is on the cliff? Well, time's going to go on no matter what. Time is most usually an independent variable. Time's going to pass whether you sit there or whether you do anything. So seconds is going to represent my independent variable. The height he is on the cliff is going to be the dependent variable. So number 2, let's define variables. I'm going to say seconds. I'm just going to call it S. And height, I'm going to call it H. All right, so the whole reason for an equation, how do I get the output? H equals, how do I get the height? Well, where does this height start? What's the starting point? He's 500 foot up the cliff. So 500 is the starting point. Now, if he's going to rappel down, what's happening to the height? Well, he's decreasing that height. If he's decreasing the height, now we've got to have a rate. How fast is he decreasing? 6 feet for every second. So, for every second, I'm timesing, and it's going down 6 feet every second. So, read the statement out in words and see if it makes sense. His height is equal to starting at 500 feet and going down 6 feet every second. You see how that matches up with our situation? All right, down here, in your own words, I'm not filling it out. This better be filled out when you take a picture and turn it in. How do you tell the difference between an independent variable and the dependent variable? Rate yourself on this concept, 0, 1, 2, 3, and 4. Take a picture and turn it in on Google Classroom.